Hello, welcome back to my tutorial. Today I'm going to share to you how to determine order of fraction. This is one of the topic in A level. So let me start with the definition of order of fraction. It is actually the power to which of a concentration is raised in the rate of equation. So for example, you have A, right? So A and then its power 2. So 2 is actually the order of fraction. So for example, if it's written like b power 3, so it means that you have to read like this. This is actually the third order with respect to concentrations of b. Okay. So for example, I have a, for example, 1. Okay. So how you read it is actually, it is a first order, which is first order with respect to concentrations of a. All right. So initial rate. Initial rate is actually the rate of reactions which determined immediately after adding the reactants, where the reactions time is very short, right? So it is very short. So for example, you have a graph like this, all right? So and then you have a rate of reaction. For example, here you have a like that. So for example, A goes to B plus C. So the initial rate of reaction is actually at this point, at the cross one. So it is actually the concentrations or the rate that you find at really in the beginning, right? So for example, this is concentration against the time. Okay, so S, right? So next is rate of equation. So rate of equations basically equations where changing concentrations of reactants changes with the rate of reactions mathematically. So we need to show that what is the order of reactants for several experiments. Okay, so in order to determine rate of reaction, we have to determine the uh, we have to vary the concentration, and then we'll get the initial rate. So the rate, so we call this one, the one that we call this one, right? The one that underlined in red is actually rate of equation. So this is rate of equation. Okay, rate of equations for the rate of reaction. And then K, in this case, is actually rate constant. Rate constant is actually rate constant, right? So we'll be determining the rate constant as well. So for example, I show you this one, right? So rate equal to K times reactant A power, for example, let's say N, and then reactant B power M. So the other terms that you need to understand is actually uh, N plus M is actually overall order of reaction for this reaction. Okay, so for example, I have this table. I have 4 experiments with different concentrations of A and B, and I also have a different initial rate. So right now we are going to determine the order of reaction. So the simplest way to do that is actually you just see, you only need to see where is the concentration of A and B constant at certain amount of equations. For example, if I wish to determine concentration of A, right? If I wish to determine concentration of A, I have to find where is in which experiment, okay, either in experiment number 1, 2, 3, or 4, where the concentrations of B is constant. Okay, all right. So for example, I wish to determine concentration of A, meaning I would like, it is actually possible for me to compare concentrate experiment number 2 to experiment number 1. Okay, so just think that this one is on the top and this one at the bottom. All right, so I just put here division, right? Division. So 0.2 divided by 0.1 is actually 2. So 2 power A. So let's say the unit for the order for reaction A is actually N. equal to B is constant. So we can actually cancel 0.1 divided by 0.1. So equal to rate is actually 0.4 divided by 0.2 is actually 2. So mathematically n equal to 1. All right. And then, for example, if you wish to find concentrations of A, right? So you already get, you have to find where is the concentration of B, which is constant, right? And then if you wish to find concentration of A, you have B is actually you have to find where is the concentration of A, which is constant. So actually we can select this 4 and 3, right? So if you wish to find concentrations of B, right, or order of fractions of B, so you have to find where's the A, the concentration of A is constant. So I may compare experiment number 4 to number 3. So I just cancel this one, all right? And then I have 0.2 divided by 0.1, which is 2 power m. Let's say the order for reactions for this one is m, this one is n, and then initial rate is actually this one. So 2.4 divided by 0.6 is actually 4. Okay, so um, mathematically m equal to 2. All right, so therefore we can actually write the rate of equation R equal to K, rate constant, times concentration of A raised to the power of 1, okay, and then multiply by concentration of B raised to the power of 2. So when you read this one, so you have to mention that rate of this equation is actually the first order with respect to concentrations of A, and second order with respect with concentrations of B. That's so simple. So again, yeah, let me repeat one more time. The keyword is actually you have, if you wish to determine concentration of A, you need to find where's the concentrations of B where's the concentration of B, which is constant, right? So which one is the constant? So you compare experiment number 2 and number 1. Okay, so let me help you here. So you compare experiment number 2 divided by experiment number 1, and in case you wish to find concentration of B, you need to find where's the concentration of A that has the same number of concentration. So meaning, yeah, you need to find which one is constant, right? In which experiment. So you compare experiment number 4 and number 3, then you can get this. All right. So I hope you learned something for today, and thank you for watching.